Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes to evaluate the true shape and size of the sectioned inclined surface of the solid. So I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the pictorial view of a machine part, and into this machine part, so here we have got a sectioned inclined surface of the solid, so which has been cut by an auxiliary inclined plane, and we are required to evaluate the true shape and size of this sectioned inclined surface of the solid. Now when we observe the solid from the front view, so we are going to obtain the edge view of this particular sectioned inclined surface onto the vertical plane, and when we observe the solid from the top, so we will be obtaining the shortened or the apparent view of this particular darkened surface onto the horizontal plane in the top view. And when we obtain the left hand side projections of the solid onto the profile plane, so once again we are going to get the shortened view or the apparent view projections of this particular inclined section surface of the solid over there. So this way, either the front view or the top view or the left side view, we are not able to obtain the true shape and size of this particular inclined section surface over there. So what we can do, we are going to project the orthographic projections in the front view, which will be providing us with the edge view of the sectioned inclined surface, and we will be projecting the top view projections of this particular solid, which will be providing us with the apparent shape projections of this particular sectioned surface over there. And now using the information available through these front view and the orthographic top view projections of the solid, then we are going to draw an auxiliary inclined plane which will happen to be parallel to this inclined surface. Now once we draw an auxiliary inclined plane parallel to this sectioned inclined surface, so the projections of these 8 points over here, so we can see point number 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 points which are going to define this inclined section surface of the solid. So the projections of these 8 points onto the auxiliary inclined plane, which happens to be parallel to this sectioned inclined surface, so these projections, they will be providing us with the information regarding the true shape and size of this inclined section surface. So let us proceed with the construction of the front view and the top view projections of the solid. So here we have got the XY reference line. The front view of the solid we are going to project above the XY reference line, while the top view will be projected below the XY reference line. So when we are going to look at the solid from the front, so we observe that the width of the solid happens to be 60 millimeter, while the height of the solid, it happens to be 58 millimeter. While we look at the solid from the top view, so we observe that the width of the solid, it is equal to 60 millimeter, and the depth of the solid happens to be 54 millimeter. So using this information, now first of all we are going to draw the rectangular faces which are going to contain all the elements of the solid in the front view as well as in the top view. So we know that the width of the solid happens to be 60 millimeter. So we have drawn the width over here equal to 60 millimeter, and this width dimension, the two projector lines, we have extended them onto the top view projections as well, because the dimension of width, it will be required even in the top view projection. Now we know that the height of the solid, it is equal to 58 millimeter. So this is the height of the solid. So now we have drawn this height of the solid equal to 58 millimeter. Now we are going to draw the rectangular surface in the top view, which is going to contain the details regarding the top view projections of the solid. So we know that the depth of the solid, this depth is equal to 54 millimeter. So the width equal to 60 millimeter we have already projected. Now we have projected the depth of the solid, which happens to be 54 millimeter, and two horizontal projector lines we have drawn in order to complete this rectangular surface which corresponds to the top face of the solid. So all the dimensions, all the elements of the top view, they will be contained within this rectangular surface. Now let us proceed with the construction of the front view orthographic projections of the solid. Now when we are going to look at the solid from the front side, that is from this particular direction, so we observe that this solid has got a rectangular slot on the right hand side, and the dimensions of this rectangular slot, they happen to be 16 millimeter, it is the width, and 20 millimeter, it is the height. So this slot, it is going to measure width equal to 16 millimeter and height, it is equal to 20 millimeter. So then we have got this top surface of the solid, for which the width will be equal to 26 millimeter. Then we have to move down by a distance of 17 millimeter. So this height ahead of this particular inclined surface, this vertical edge, it is going to measure 17 millimeter over there. And then from this side, we'll be able to observe that at a height of 18 millimeter. So this inclined surface will be starting and it will be ending up at a point once you move down 17 millimeter from this particular edge over here. So this will provide us with the edge view construction of the cut section over here. So this is the inclined cut surface section. So we have to obtain the edge view of this inclined cut surface section in the front view. So let us proceed with the different elements of this particular solid. So as we have discussed, so on the left hand side, the height of this particular vertical element of the solid, it happens to be 17 millimeter. So once I mark this height is equal to 17 millimeter, a horizontal projection line we have drawn over here. Next, once we look at the solid from this side, so we observe that we have got a rectangular slot on the right hand side face of the solid, such that the width, it is equal to 16 millimeter and the height, it is equal to 20 millimeter. So we must remember that this height is 17 on this side and the height of the vertical edge on the right hand side, it happens to be 20 millimeter. So both these edges, they are not equal over here. That is this vertical element and this vertical element. So the heights, they are going to be different. So 20 millimeter we have measured from the top, and another horizontal projection line we have drawn corresponding to this height of 20 millimeter from the top. Then we know that the width of this rectangular slot happens to be 16 millimeter. So we have marked the 16 millimeter along the width, and then we have got this horizontal top surface. So this is measuring 26 millimeter. That is 16 millimeter from the right hand side. We have got this rectangular slot. Then 26 millimeter further as we move towards the left hand side. So we are able to achieve this top surface of the horizontal web over here. So this is the top surface of the horizontal web which we have got, right? So this is the top surface we have obtained. Now let us draw the vertical projector lines. So once we draw this vertical projector line, so we can see this is going to be my rectangular slot. So this one you move down by how much? 20 millimeter. Then you move towards right by 16 millimeter. So this rectangular slot which is available on the right hand side will be located onto the front view. Similarly, another thing we need to remember over here, that this inclined surface, it is going to start at a height of 18 millimeter from the bottom or the base. So we measure 18 millimeter from the bottom or the base on the left hand side portion of the solid. So this is the left hand side portion of the solid. So from this point, our inclined surface, it is going to start and it will be ending up at this position. That is where my 17 millimeter vertical web, it is going to end over here. So from this point If I join this point, I'll be able to get the inclined surface edge length over here. So this will be the edge view corresponding to the sectioned inclined surface of the solid. Now another thing we need to remember over here, that there is a slot over here, there is a vertical slot into this element. So this is the inclined element of the solid. So into the inclined element of the solid, there is a vertical slot which is having the width equal to 9 millimeter. So even though this slot is not visible to us from the front view, but corresponding to this edge, we are going to get a dotted line or a hidden line projection over here in the front view. So in order to project the location of this particular web thickness over here, so this is the thickness of the rectangular slot. In order to project the projection of this surface of the rectangular slot which lies in this inclined portion, I have to mark this particular dotted line over here. So I have to mark the vertical projection line starting from 9 millimeter from the left hand side face of this particular solid. So this completes the construction of projection lines regarding all the elements of the front view. Now let us move on to the top view. So when we are going to look at the solid from the top, so three things we will be able to see. First is this rectangle, which happens to be 16 millimeter wide and 54 millimeter deep over here. So this is the projection of this rectangular slot which we had got on the right hand side, this slot. And then we have the rectangular face. So the projection of the rectangular face has also been obtained over here. So the two faces we have been able to obtain over here in the top view as true shapes. Then we move on to this particular slot. So we know that we have got 18 millimeter from the rear end. You move forward and then you have the width of this rectangular slot equal to 18 millimeter. So once we have this 18 millimeter width of the solid at the center, so we are going to draw two horizontal projector lines over here. The moment we draw these horizontal projector lines, the top view of this inclined surface for corresponding to which the true shape needs to be evaluated. So this top view of this shaded portion has been obtained. So let us see. This is the top view of the shaded portion. So this is the top view of the shaded portion over here. So this way, so all the elements of the solid in the top view, they have also been located. Now what we are required to do, we have to darken the edges which are visible to the observer. So as we can see, this is the vertical edge at a height of 18 millimeter. So this we have darkened. This is the base of the solid which is visible. Again it has been darkened. This is the vertical edge on this side of the solid on the right hand side. So again this has been darkened. So this is the rectangular slot. So this portion, edge of the rectangular slot, will be visible to the observer, and we must note that this height of the vertical element on the right hand side, it happens to be 20 millimeter, while the height of the vertical element on the left hand side, it is equal to 17 millimeter. Then you have the top surface which will be appearing as an edge view in the front view. So this surface is visible, this surface is visible, and then this is the edge view of the inclined section surface of the solid and or the shaded portion of the solid. So this way the front view has been obtained, but this portion we haven't drawn till now. That is a vertical edge over here which will be a dotted one, since this is not visible to the observer from the front end side. So at a depth of 9 millimeter from the front face, right? So at a depth of 9 millimeter from the front face, so we have to plot a rectangular slot over there. We have to draw a rectangular slot over here. So corresponding to this slot, we have got a dotted line. Let us plot the top view. So top view we have already discussed. Corresponding to this rectangle, the true shape of the projection is lying over here. Corresponding to this surface, this is the true shape of this rectangular surface which is lying on the top of the solid. Now here we have got the apparent shape of this inclined cut section over here, which is appearing as a shortened view or an apparent view in the top view projections over here. So this is apparent shape, this is true shape, and this is true shape. And once we are looking at the solid from the front, so this is true shape projections of this particular face. And again, this face, it is also appearing as true shape in the front view projections. Now, we have got the front view projections, we have got the top view projections, and we observe that there are 8 points which are going to define this shaded portion, surface of the solid over here, which happens to be inclined section surface. Now, let us mark these points. So this point will be point 1, this point will be point 2, this point happens to be point 3, then we move on to point 4, 5, 6, 7 and 8. So there are 8 points which will be required to define this inclined section cut surface of the solid. So once we define these 8 points, so these 8 points we have already defined in the plan view: 1, 2, 3, 4, 5, 6, 7 and 8. And we have also defined these points in the isometric projections view so that we can have a better understanding of this face which has been represented as an apparent shape in the top view projection. Now let us mark these points onto the front view. Now please check, if I am going to look at the solid from the front, so points 4, 5, 8 and 1. So all these 4 points, they are going to lie in the same orientation. So these 4 points, they will be coinciding with each other as we are going to look at these 4 points from the front view. So they will be located over here. So the front view corresponding to these 4 points will be 4 dash, 5 dash, 8 dash and 1 dash. It is corresponding to this corner point. 4 dash, 5 dash, 8 dash and 1 dash. They will all be appearing over here. Then there are another 2 points. Once we are looking at them from this side, so they will be also coinciding with each other. If I extend this edge over here, so points 6 dash and 7 dash, they will be appearing over here. And finally 3 and 2. So once we are going to look from this side, so we are going to get the point view corresponding to this edge. So points 3 dash and 2 dash, they will be located over here. So we can check point 3 dash and 2 dash, they have been identified and located over here in the front view. Point 6 dash and 7 dash, they have been located over here. And there are remaining 4 points, 4 dash, 5 dash, 8 dash and 1 dash, which have been located onto the edge view. Now all these 8 points, they have been located onto the edge view of this particular projection. Now what we are going to do, we are going to draw an auxiliary inclined plane x1 y1, and this is auxiliary inclined plane which will be parallel to the edge view of the inclined cut surface section over here. Now the projections we are going to draw from these 8 points onto this AIP. So since these points, they have been clubbed, so 4 points, they were lying at this orientation, 2 points, they were lying at this location, and 2 points, they were lying over here. So 3 projector lines which are going to correspond to these 8 points which are available to us in the front view projection. So 3 projector lines we have drawn perpendicular to the auxiliary inclined plane. So these projector lines, they have been drawn perpendicular to the auxiliary inclined plane, and the projections of all of these 8 points which will be obtained on this AIP will provide us with the true shape of this inclined cut surface section of the solid. Now let us start with the construction of this auxiliary plan. So we know that while we were drawing this top view projection, so this distance was not given to us. So this was taken by us randomly over here. So this distance which is not fixed, so this distance I have marked as distance x. So once I mark this distance x, so this distance x will be transferred onto the auxiliary inclined plane, and I am going to draw projection line which will be parallel to this x1 y1 auxiliary inclined plane. And the moment I draw this projection line parallel to AIP, now please check, I am able to identify these 2 points, point 1 and point 2. So point 1, it is at a distance x from the vertical plane. Point 2, it is located at a distance of x from the vertical plane. Now on the corresponding projection lines, I will be marking these 2 points as 1, 1 and 2, 1. So this is the projection line corresponding to 1 dash, right? And this is the projection line corresponding to 2 dash. So over here, I will be able to obtain the point 1, 1. Over here, I will be able to obtain the point 2, 1. Right? So these 2 points, they have been located 1, 1 and 2, 1. And then we can see that this distance, it is equal to 18 millimeter beyond this distance x. And again, this distance is again 18 millimeter beyond this distance. And finally, the total depth of the solid happens to be 54. So this distance, it is also equal to 18 millimeter. So we have divided the depth of the solid into 3 equal parts. This is 18, this is also 18, and the remainder portion, it is also 18. So we have drawn the 3 distances of 18 millimeter depth of the solid over here. And now once we draw the 3 projector lines parallel to the auxiliary inclined plane, so the remainder points we will be able to identify. Now you can see that as we move ahead of this point x, so as we move ahead of this point x by a distance of 18 millimeter. So here, as we move ahead of this distance x, so as we move ahead of this distance x by a distance of 18 millimeter, we will be able to identify and locate the points 8 and 7 over here, because the distance of points 7 and 8 with respect to the vertical plane happens to be x plus 18. So we can check, as we are moving ahead of this distance x by a distance of 18 millimeter, so onto the projection line corresponding to the point 8 dash, we will be able to locate point 81, and corresponding to the projection line which is available with us corresponding to the point 7 dash, we will be able to locate point 71 over here. So 81 and 71 points, they have been located in the auxiliary plan view. Similarly, as we proceed further, we are going to obtain these 2 points 5 and 6 over here. So these 2 points 5 and 6, they are lying with respect to this vertical plane at a distance of x plus 36 millimeter. So x plus 36 millimeter distance from the vertical plane will provide us with the location of these 2 points 5 and 6. So here we have got projection line corresponding to point 5 dash. So it is this one. So as we move along this line, so here at a distance of x plus 36, so the point number 5 will be located. And similarly, this is the projection line corresponding to the point 6 dash. So as we move along this particular projector line, so at a distance of x plus 36, the point number 6 will be located. So this is the location of point 51. This is the location of the point 61 over here. And finally, as we reach this particular end, as we move still further by a distance of another 18 millimeter, that is x plus 54 millimeter. So once we reach this end of the solid, so the points 4 and 3 will be located. So let us work out the origin points corresponding to the projectors for these 2 points 4 and 3. So here is the location of the point 4 dash. So on this projector line, as we move distance of x plus 54 millimeter over here, so we will be able to identify the point number 41. So this is point number 41. Similarly, alongside this particular projector, which is corresponding to the point 3 dash, as we move along up to a distance of x plus 54 millimeter, so we will be able to identify and locate point 31 over here. So this way, all the 8 points which have been marked over here, or you can say all these 8 points which have been marked over here in the top view or the isometric projection, they have been appropriately located in the auxiliary plan view. So once we join all these points, the edges corresponding to the true shape of this sectioned inclined surface will be obtained in the auxiliary plan projection. And since we had drawn this auxiliary inclined plane parallel to this edge view, so this shape which has been obtained over here corresponding to the shaded portion, so this will represent the true shape of the cut inclined section surface of the solid. And now if we compare this true shape with the apparent shape which we had obtained in the top view projections over here, so we can see that the apparent shape projections, they appear to be shorter or smaller than the true shape projections which we have obtained in the auxiliary plan projections over here. Now we can shade this portion so that we can have the correlation that the shaded portion is corresponding to the inclined cut surface section over here, and this is the auxiliary plan. So another name of this plan, we can say that it is the auxiliary plan. Why? Because the projections obtained on the AIP, they are called auxiliary plan. So using this information available in the auxiliary plan, we have been able to derive the true shape and the size of this inclined cut surface section using the auxiliary plane method. So this is all for today. So we'll be continuing with further discussion regarding few more applications of the auxiliary planes in the coming lectures. Thank you very much. Thanks a lot.